I'm second year PhD candidate, and I work with architecture department, and also I am part of Peruvian architecture engineering department, BDG group, and my advisors are Ursula Gashford, thank you for being here, and also Nathan Brown. And my subject today is connected to my thesis, and what I'm going to present is about reducing embodied carbon through structural design, and the focus is about the effects of column grid layout decisions. When we talk about carbon reduction, one of the first things that came to my eyes is this building. Let's go vertical. This building annually, it can absorb about 18 tons of atmospheric CO2, which is beneficial. But there is a factor about this building that many people do not know. This building in a construction part means in the first stage that they were like building this building, 990 tons of CO2, which makes us think how we can solve that. Instead of, yes, that is good to have a greenery to cause carbon reduction and absorbing, but what if we can reduce this amount in the first step? However, I'm not the first person to think about this idea. It has been the case that many people think about it. And I put two of the examples in here. One of them is about concrete, that you can have different slab thickness based on the forces. And the other one is a church, which they use a stone skeleton structure. And again, for this one, they try to reduce the amount of material that they are using for their building and make it more efficient. Both of those designs trying to reduce the material, but ours gonna do the same, trying to optimize the amount of material that we use in a structure, but with a specific focus, which is column grid layout, something that is difficult to code. And most of the architects try to be more free in a way that they are designing, and they try to, but the connection to the next step, which is structural part, architecture engineering part, is more challenging, and we try to see how we can make it easier in the process of design. But before jumping to the next step, when we are talking about material reduction, reducing amount of material, what we mean? It means that we want to reduce embodied carbon. But for talking about embodied carbon itself, we need to know a little bit history about it. What's happened, how it's started, and what we are right now. I'm going to talk about the 1970s, which is the energy crisis, or where people understand about embodied and operational energy, and trying to see they face the challenges in that time. And in 1990s, people reached to the part that they established different standards like ISO, but also they start to understand about life cycle assessment of the building. Understand it isn't only the last stage that is emitting the carbon, which is operational, like utility that you pay, but it is about embodied energy that we are emitting from the time that you are going to a mountain and mining the material. And in 2000, there was a huge change. From embodied energy, we are reaching to embodied carbon. There was a main idea behind that. Embodied carbon gives us option of connection to global warming. It gives us what's happening in the real world, and we try to reduce amount of carbon based on the material that we are choosing. And in next decade, we have a green building. What does that mean? It means that many manufacturers try to collect the data connected to the material that they are producing. And it was a really hard process before that. We couldn't imagine how we can reduce it or which one of them had a lower carbon compared to the other one. But having files like EBT5, environmental productivity are the ones that have been start to be produced in green building decades. And then where we are right now, green regulation is needed. Like in past, we would be asked people that yes, that would be good to consider carbon reduction, but not this decade. We have to change them to be a code, something that we must make changes that we improve amount of carbon emission at the end. But in this process, it is important to see what other things was connected to different decades and different years. which it is connected to my thesis, tools connected to carbon reduction. And different methods, we have different tools based on the need of that specific years or need of the industry. One of them is Athena, one is Italy, and many others. And among them, there are several of them that connected to earlier stage carbon reduction. But what does that mean? We have tools connected to early and later stage of design. And those are the part that it shows the amount of effect that designer can have. But it is not limited to that aspect. If we, let's ask a question. How many of you think designer have the highest amount of impact? In the earlier stage, later stage, or any other aspect? The answer is connected to life cycle assessment of the building. When we are thinking about this process, which is connected to embodied carbon or embodied energy, we are seeing this whole process. We should start from mining, go to the site, go to the manufacturing site, and then if you're gonna recycle that, or it's gonna go to the landfill. But the effect of design in this process is important. And it starts not in this cycle, but before this cycle even starts. This is based on the research that has been done. Earlier stage of design, which is disconnected to the concept, the one that you are designing, the floor plan that you're trying to make a shape in the first stage, earlier stage of your design. And then you have a later stage of design. You have your structure, you have your building. You can change only material based on what the structure you choose in the first step. And then you have a maintenance process. And at the end, you have a recyclable if there is any to work with, and change the design based on what you have. And between all of those, earlier stage by far has the greatest impact on the design process. And is the one that has been ignored for many years. And we are trying, especially in a structural system, as a designer, not as architecture design. And based on that, our focus for the tool that we developed was earlier stage. We want to see how we can solve the problem. But we didn't stop there. As I mentioned, there are many tools exist connected to earlier stage. So what we are doing that others they didn't, and we try to cover this. There are two main factors. First one is many of them give the option to estimate the floor plan, and based on floor plan, they are giving you the amount of structure carbon emission at the end. And for example, for the same area, different shape, you're gonna get same result. For many cases, not all of them. Some of them partially give some option like pre-optimal. So that is one of the aspects that we are working on. And the other one is color grid layout. The only thing that you see in all of the tools is a span size. It's giving you, for example, from 2 span size, it can change to 5 or 6. And most of them, they estimate the rest based on the average amount of column that you can have. But that is not good enough. We can do better. We can work with architects as an architecture, engineering, and all both work together to come up with a grid that it is more acceptable, because common grid layout is connected to a slab size thickness, and that is a huge amount of carbon that we are emitting at the end. So based on this idea, we start building our own tools. The tools can start having two objectives, which is CO2, carbon reduction, and the other one, maximum bending moment. However, we are working on that one. I consider a little bit of step back based on a publication, because right now we are working on a structural volume instead of maximum bending moment. And in this tool, we have parametric. Some of the data are like the parameters for us. One of them is floor height, and the other one is floor number. Those are the factors that they are changeable, but we cannot ask, okay, to reduce amount of embodied carbon, have like 2 floor instead of 10 floor that you needed. So there are parameters based on what you need, but they are changeable, definitely based on what your project need to have. The other one is variables. We have Variables in here connected to non-orthogonal shape. You can add the shape connected to non-orthogonal floor plan. And the other one is the span size. We have another one which it is again in the process, which is overhang. But up to now, the one that I'm presenting, the result is connected to these two variables. And based on what we have, we can give you several different scenarios. One of them is like simple, we can give you different span size effect like many other tools. And the other one is more challenging, is give you the result based on different shape of floor plan. And the last one, which is the most interesting part, is connected to performance evaluation. What does that mean? The thing that we are doing is we are focusing on how we can offer good column grid layout to design. And for doing that, it means that we are trying to keep our column grid layout, for example, 4x4, but going even one step beyond that. Because we can change the location of column grid layout and have a different grid layout based on where you are putting and connection to having the amount of overhang at the end. Based on what I said, okay. Let's see how it's working. These two are two of the floor plan that we try to see what is the result and give us at the end. We try to, in this stage, see if we are changing the location by having, like, for example, 4x4 grid or 8x8 grid, how it's gonna change for us. And it shows this one is more challenging and this is less challenging. As an architect, it is harder to understand how one of them can be more challenging and end up in a bad result compared to the one it is like easier to work. The reason is we are trying to understand the result of us based on amount of overhang. And overhang is connected to the edges and many other factors to understand how maximum bending moment can work. It isn't only overhang, but also other factors. And the result on the top corner, you see, belongs to this one. If it is all in the same line, it isn't any problem to work with a different grid. But then we end up design like this one, which is many one of us face that. We can lead to unexpected result in a maximum bending moment and have a bulkier structure, which will need a huge amount of in-body cap. So what we are trying to do here is we try to give the best option, optimized option to the designer. Instead of asking them, okay, you design, let's see how you can reduce the carbon, you're offering them how you can do it by the tool. But I'm gonna ask you a question. We have a parametric tool, it gives tons of different options, and we give you the best answer. Is it something that architects would use? Reaching to the best final answer? Not in the most case. They don't like a structure design, give them the layout to work with and force them to work with the limitation that exists. So there is a huge problem in here, and our tool is not the only one, and we have many other tools that are facing the same thing. And we are calling that energy, embodied carbon, want to reduce it, but it doesn't happen that often. Although we have many tools that they can improve it. So we are reaching to the next step, which it is, we need to have a structure exploratory system. What does that mean? It means that in this section, instead of cleaning architects from the whole process of optimization, add them to this process. It's try to see what they need to give them the answer that they want at the end. Not one best answer, but several that they can work with. We have to understand how we can walk through with the architects, not only give them the best answer. They are the one to go for the layout, see where the column should be. The spacing work for that. Even one column in a wrong location can mess up the whole design. So that is the part architects should be part of it. And for doing that, we are going one step back. Where those, we want to have a structure exploratory system. And how we can reach to that? We have to understand how architects think. We have to understand how designer intuition works. in a different step of the process are designed. For understanding that, we are doing an experiment. This experiment starts with a survey at the start, and then we are going to see how they are working when they are doing the sketches, which many of the designers are doing that. And at the end, we are going to do this continuous experiment. We are going to see how main experiment, which is connected to tool, works. And we try to analyze how designer work in those environments. How we can analyze this process is important for us. Many people end up, we are using different methods. Many people end up in a cognitive design format, which is a talking loud survey, and just the whole process will be finished there. But for us, intuition is really hard to capture. It is something that it is a moment that we are talking about. It isn't something that you are bringing reason, but it is something that you are having it based on, I want to say, immediate answer that you are giving, based on experience, many things that happen in the brain. So for that, we are not only asked participating in this process, talk loud, but also we are having physical cognitive format, which is heart rate and eye tracking system. And then we have a third part, which is an interesting process to understand, which is neurocognitive process. We are using FNIR, is a cap that we are putting on the head of the participant to see when they are doing the experiment, how they are, which part of the brain is going to be active. We have the default mode, which is connected to relaxing part of the brain, and the funny part is the relaxing part of the brain is connected to creativity. So, and we can capture those things, but all of them have to work together that we can say what's happening here. And the next step is we are not going only to do this experiment in one only experiment, like it isn't one series, it is a different one that we can compare the data with each other. We are going to see how giving the feedback and not giving feedback on results, how different priming can work, and different number of variables can affect the design. So that the experiment that you see, the whole process is going to be simultaneous with a different format and the inside of that to be able to compare them at the end. And that was the whole process. Thank you so much.
Thank you so much, Parinaz. The next presenter is Tausif Al-Nasser.